Hello everyone and welcome to another episode of Curious Currents, the marine biology podcast where two curious minds learn about the wonders and the weirdos of the ocean together. My name's Emily, marine biology graduate with a passion for storytelling.
And I'm Shiv, the one who asks questions.
This week we're unpacking why cephalopods are so good at hide and seek. These animals are renowned for their ability to change colour and the texture of their skin to perfectly match the environment, despite the fact that most of them are actually colourblind. So join us as we learn the mechanism behind this ability, why it evolved, and how they have used it to create their own language. So without further ado, let's investigate how they do it.
I love that I don't look at these beforehand very often. And I always, if I do look at them, I specifically miss out your last little few lines of that paragraph, so I get the honest reaction of those crap puns.
And you laugh every time.
I do.
So.
I do have a question though already.
Mm-hmm.
So you were saying they change the texture of their skin?
They do indeed.
I thought it was just like PETA, like, you know, in Hunger Games, that he can like texture his skin because it's like he's good at contouring.
No, they have like little bump things under their skin. We'll get into it somewhere, but they have little bumps under the skin that they can move, make bigger, smaller.
Okay.
Yeah. So, in a game of hide and seek, who's winning, a sea slug or an octopus?
I mean, I want to say octopus.
I mean, yeah, I for sure think an octopus would win. Their chromatophores are way more advanced. But I went looking for sea slugs the other day.
Yeah.
Could not find one for the life of me, even though I knew, I was like, I know they're in there. Because this is the exact habitat they would be in. It's like a rock pool, it had seaweed, it had anemones in it. I was like, I know. And the seaweed had like bites taken out of it. So I was like, there's something munching on this.
Yeah.
I just couldn't see them for the life of me.
But could you see an octopus either?
Probably not. No.
I think in the best way possible, something better than you needs to be looking for it. For that to be a competition.
Yeah, you gotta be adapted for finding these things.
On a scale of you finding them, I think you don't have a chance on either one.
But I would be so excited.
You'd be so excited.
I'd be so happy. Cephalopods are so good at changing their colour because they can neurally control their chromatophores. We talked about chromatophores before, but to remind folks, they are pigment-filled sacs that are controlled by muscles that either contract or expand to make the colour more...
Vibrant?
What's the word? Yeah, vibrant. They're more like organs than just cells because they can be controlled by muscles and by neurons.
Okay.
So
is that different to how the sea slugs would do it?
It's different because sea slugs get their colour from what they eat.
Oh.
So they eat the anemones and then they take on the colour. Some of them are able to change their own colour by different colour changing cells, but it takes a lot longer and it's a lot less sophisticated than
so it is like a slower transition as well. So the octopus are definitely smoking them in a game of hide and seek, unless they've had months to prepare
octopus
and the correct meal
instantly.
Yeah. Oh, which would win, a gecko or an octopus?
An octopus.
Oh,
lizards,
answer that so quickly.
Lizards are slower at changing their camouflage, and
you heard it here first, folks.
And they're more limited to what they can do.
Okay.
There's 3 different main categories when describing octopus coloration. It's either mottled, uniform, or disruptive.
Okay, can we go through those?
Yes, we can.
Uniform?
So uniform is when it's mostly the same colour if it's trying to match one texture, like the sand.
Okay.
It'll be the same colour as the sand.
Oh, okay.
If it is mottled, it's slightly more speckled, a bit more pattern going on. So if it was trying to match like a coral or a reef, different rocks that have maybe different colours on them, it'd be a bit more speckled, or a rocky bottom. And disruptive is more bold, distracting colours. So that's kind of like what
blue
cheetahs
ring
do. Yeah, or like what cheetahs do, where it's like just to disrupt.
Cheetahs?
Cheetahs.
Oh, cheetahs.
Yeah, like they
Oh, I
don't
was
match their background, but
Yeah.
they blend in because the coloration, it like does something to your eyes.
Mm.
So they can make themselves be drastically contrasting, and it just
Works.
works. You don't see it.
Here, eyes, super, super smart, but super, super dumb. Because the contrasting stuff, they autofill.
Okay,
Well, I suppose it's not your eyes, it's your brain.
Yeah.
Your brain autofills in and you're like, that's wrong. This is what you really see.
Yeah.
And it autofills in and you're like, no, that's wrong. I don't see, like, the optical illusions or whatever that your brain autofills in.
Yeah, that's what it's like. That's what the disruptive is like. It's
Yeah.
like an optical illusion. You can't see it. But these pigments usually contain like black, brown, yellow, orange, and red, and they're controlled
The primary colours.
Yeah, they're controlled by. Well, orange isn't the primary color.
It's close enough to red.
They're controlled by motor neurons from the brain, which stimulate these like radial muscles are called around the opening of the sac, and then when they fire, the muscles contract, so the sac expands. It's like if you imagine a balloon and you have ink in a balloon. If you just hold the balloon, you can't really see it, but if you squeeze, it all gathers in the one area.
Yeah.
and
Oh, it's
it
like
looks a
those
lot more
toys that you get,
concentrated.
like
Yeah, the fidget toys. If you
Yeah.
squeeze them, and you can see all the liquid.
Yeah.
That's what it's like.
Do you think, or is there any way to know whether or not, like, you know the way our brain does stuff and it's automatic and we don't, like, knowing how to breathe, you don't forget how to do it and your body does it automatically, but your brain is telling your body to do it? Do you think the changing colors is more like, is it more like talking where, like, we tell ourselves to do it and we learn it? It's mostly like or like movement where we are like specifically moving our hands and like moving, or is it like
put a
breath?
pin in this point.
Ooh.
I have a lot to say about it later on. But I like your thought process.
Yeah.
We'll go back to like
The orange, yeah,
chromatophore
they're
stuff just now.
controlled by
They're
motor
controlled by
neurons.
motor neurons. It's like a balloon or like the fidget toys. Most other animals, going back to when you're talking about geckos, use a hormonal process to change their colours. It's not
So
a
it's a little
neural
slower?
connection, so that's what makes it slower. They control the amount of the expansion as well, which is what controls the intensity of the colour. So it's not just a super relaxed or super contracted.
Yeah.
It can be things like in between as well. The chromatophores don't tend to be controlled individually, but it's more kind of like a pattern generator, like a coordinated movement. And thousands of cells are activated simultaneously to create like stripes, waves, and spots. So it's like the skin is the monitor, and the brain is like the graphic designer that processes it. Cuttlefish are particularly good at camouflage and using different colours. I know I brought up cuttlefish before and you were a bit like, what the fuck is a cuttlefish?
Yeah, you're gonna have to remind me again.
So cuttlefish look kind of in between an octopus and a squid. They're like...
Here, octopus and squid already pretty much look like each other. Oh, weird. You should for sure look up cuttlefish, guys.
So they have 8 arms, 2 tentacles. Do you know the difference between arms and tentacles?
No.
Arms have suckers all the way down the length, but tentacles only have suckers at the very bottom for grabbing stuff. So octopuses do not have tentacles, they only have arms. Squids and cuttlefish do have tentacles. There you go.
Huh. Top tip for identifying.
They have weird W-shaped pupils. They're about 10 centimetres.
Oh my god, they do! I didn't even notice that because it was so weird. What freaky little eyes.
They also have the largest brain-to-body ratio of the invertebrates.
They are very megamind.
Yeah.
They are very megamind.
They're different from octopus and squids because these guys have internalized their shell, and it's not really a shell anymore. It's been converted through evolution into something called a cuttle bone that they use for buoyancy.
And what have octopus and squid done with their shell again? Is it gone?
They don't have it.
Yeah. Okay, I was like, wait.
Gone.
Oh yeah.
Threw it out the window.
Yeah.
So yeah, that's what the cuttlefish is. And they are particularly good at changing their patterns. They've been noticed by some scientists. They did like experiments on them, observation experiments, and noticed that they kind of go through like a Rolodex of patterns until they find the one that's best.
That's kind of cool.
In a new background, they're like, they do something and go, oh, that's not quite working. Let's edit this bit and then change it and then keep changing it until they seem to be
Modern day
satisfied.
Shark Tale, right? My pitch for... I have nothing else about the movie, right? But if they're in a casino at some point, they could be the like, you know, the things that you like, the jackpot things where you like grab the handle and it like rolls through stuff and you have to get 3 cuttlefish to match.
Or it's just on the cuttlefish, like
Yeah,
one side
yeah,
got like
yeah.
the lemon. Yeah.
That'd be cool.
They're also known to turn very pale when they're under threat, which is known as blanching. Octopuses also do this. They go super white, and apparently it's to kind of freak predators out. So like, oh, what was that? And then they can go away, like to distract them.
Oh.
There'll be a colour and then suddenly bright white. The predator's like, what? And then they're gone.
You all be freaky.
They could also, so the sudden white flash is because they relax all the muscles that are controlling the pigment sacs. And it's been suggested that this control for this is a separate neural pathway that overrides anything that's going on right now. So it's kind of like a panic button. Press it, flash white, gone. What?
It's kind of like that red phone, like that can cut through it. Like there was it like in movies. There's like a red phone for like if nuclear war is breaking out, they pick up the phone on a red phone. Oh.
And they think that happens because the original pattern remained, but it was just kind of paler. So it's kind of like superimposed. The white was superimposed on top of the original pattern. So that's why they think that
they
it's
didn't
a different.
Just run out of ink. No cartridges need
like
to be changed.
Low toner. Yeah. There's different types of colour cells. So you've got the chromatophores. You also have iridophores, which are stacks of reflecting plates that are made of something called chitin, and they create a kind of iridescent colour. So that's what creates the blue in the blue ring octopus.
Plates of
Chitin.
You know what's really funny? That's a really common thing to be dropped in monsters in a lot of the games that I play.
What?
Chitin. And I always call it chitin. Like the CH, the ch.
Well, no, no, it's chitin.
Chitin. Yeah. They never make things easy for us dyslexics, do they?
No.
But like that's like you make armor out of it, and like it's like that plates from that.
Tough, yeah.
Yeah, that's cool.
And there's also leucophores, and they scatter light to appear white, so they reflect different types of light, and they can also been suggested that they can control the intensity of the chromatophores by reflecting white on the background, and then the chromatophore colour is on top.
Wait, I don't understand that. I thought they were white.
No, so they reflect different types of light.
Okay.
So that they appear white. Okay. And they can be stacked and layered underneath chromatophores. So like if you paint a grey wall white first and then put a colour on top of it, it's going to look brighter than if you just painted it on the blue wall, on the grey wall.
Oh yeah, but what do you mean they're stacked on? As in, like, do they sit on top of another animal?
Yeah, they can be layered within the skin of the cephalopod. These types of different cells are all layered on top of each other.
Okay. Oh, so this could all be in one octopus?
Yeah.
Oh, I thought you were saying these were different branches. No. I think we might need to. I might not be the only one who was lost there.
Okay, I'll go back.
So these are all types of how they use the color changing, and some of these can be found in the same ones, and it's a mix and match of these different methods for color changing.
Yeah, that allow them to change their color and create such intricate backgrounds.
Okay, because I was like, okay, cool. So one type does this, one type no, but it interlays
combined.
all of these different methods.
Yeah.
For the different animals. I get you now.
Yeah.
Okay.
And then the bumps that we mentioned earlier, I don't know how to say this, so anyone feel free to correct me, because I was saying it papillae, are the bumps on the skin that can be manipulated and changed, grown, shrunk. Squids, because I've mentioned octopuses a lot, squids use the same mechanism, but they usually, instead of using it to blend in, they use it more for making flashes and stripes rather than to blend completely in. For example, my favourite squid, the humble squid, when it's threatened, it turns a bright crimson, and people nicknamed it the Red Devils because when people were on fishing vessels and they saw them, they were just flashing bright red. Red Devils.
Okay, look, it'd already be pretty insane to see half of the shit that's in the ocean.
Oh, yeah.
But, like, you really do have to be like, yeah, fair enough for making up all the monsters. Like, Because one guy was and the red devil was after me, and then somebody else heard it, and he's like, oh, there's a red devil after him, like
if you can't just Google a pic.
Yeah, or not even Google a pic, just no matter how you retell a story, you're always gonna add a little bit more to be like a little bit of spice. I get why they made up monsters.
Yeah, the Humboldt squid also really cool. Are able to create flashing and flickering patterns to mimic like the water surface.
Ooh,
cool, right?
Yeah.
Mm-hmm. Cephalopods are also able to use their arms to match the background. So they can clump them together to make them look like rock, and they can also make their arms go rigid.
Oh.
Yeah, that's because they're just muscle. They're just like pure muscle.
Yeah.
They can tense them and make them go rigid. That's what helps them walk.
Sun's out, guns out.
Yeah. Them being kind of rigid is what helps them walk along the seafloor as well. Yeah. They're also masters of behavioural mimicry. The mimic octopus is really good at mimicking venomous predators that also have striped patterns. So it's like black and white striped, and it's about 2 foot long. So it imitates like the banded sole, a lionfish, and a banded sea snake. Yeah, I think it's funny when it does the sea snakes. It kind of just stretches its arms out either side like it's in the splits. And then slithers along.
See, I just had an image there, but like spreading out in different. Does it like split them in half? So like, does it split? Half the arms go left, half the arms go right.
Yeah,
that is quite cool. It's cool that they do lionfish, because lionfish seem like they suck. I've never heard a good thing about a lionfish.
They look cool.
I've only ever on Instagram. There's this guy that bops around and he's like. And he's like just spearing them, and he's like, there's no way to get he's like, I'm doing what I can, but it's really it's a losing battle.
The mimic octopus also has its own mimic. Okay. So there's something called a harlequin jawfish, which is quite small, and it swims close by the octopus because its coloration has evolved to match the octopus, so that it can swim near it and not be detected by other predators that are going to eat it.
Wait, so does it change when the octopus changes?
No, it just is the same colour as the octopus.
But the octopus changes colour.
Oh, I see what you mean. Yeah, when it's most commonly got the striped pattern, this octopus, because that's what the predators look like. So this fish just looks striped. So if this particular octopus changed its colour and didn't look stripy anymore, the fish is useless.
The fish is fucked.
Yeah.
You're on your own, pal.
So if the octopus decides, you know what, you've been bugging me, man. You've been swimming, no personal space. I'm just going to let this barracuda come get you. I'm done.
Are these octopus social or non-social?
No, most octopus aren't very sociable.
Oh, yeah, I didn't think they were. The last we heard were stabby,
Yeah, it's a pretty common. I found out that not just for the blue ring octopus.
Oh, yeah?
But other octopuses, when they're reproducing.
Mating.
Yeah. It's common that they do have a separate arm that they give the sperm packet to the female, and then they just attach the arm. They're just like, okay, bye.
Oh, yeah. Oh, they do ting tong dash.
Yeah, they do. Some of them do put it in themselves and then they swim away, but it is a common adaptation that they just disconnect that arm for their own safety.
That's so funny.
Yeah.
That's I wonder in a million bazillion years will a praying mantis just detach its head and regrow another one?
What? Why?
Because that's what they do. They eat the partner's head, don't they?
Oh, I didn't realise they specifically went for the head. I thought they did.
I thought, I'm not the person to ask, but I thought so.
Camouflage is not their only mechanism for defence. They also have ink. And I learned that ink can block the smell and taste receptors.
That's really good.
It's specifically effective with sharks. They rely a lot on their smell.
That was, up until some of the most recent ones, the worst, most ineffective things on Mario Kart.
Yeah, until recently. Now you actually can't
Now
see.
you like genuinely can't
You
see.
really can't
Also,
see.
do you see how I was going there and I was like being all serious about it, and then I brought in Mario Kart?
Now you may be surprised to learn that cephalopods can do all of this amazing pattern producing and camouflage while being mostly colorblind.
That's wild.
They can't detect color visually, because their eyes only have one photoreceptor, but they can detect contrast, brightness, texture, and something we learned about with the mantis shrimp, polarization.
Oh, yeah.
To recap, because some people might not have heard that episode or have forgotten.
Me.
Both. So polarization is the type of a specific wavelength in a specific direction of light. The only way we can see it as humans is if there's glare off of something like a puddle, and there's glare coming at us, and that's why we have polarized sunglasses, because it blocks polarized light. But that's the closest we come to seeing it. Being able to recognize contrast, brightness, texture, polarization, combined with the color changing organs like chromatophores, mean that they're just statistically likely to match their environment. It's not them looking at it and going, I'm gonna dress like that rock. Huh. They just kind of go with it based on what they can see.
I'm vibing with this rock.
Yeah.
That's crazy.
Yeah. However, they do rely on their eyesight to detect predators, prey, and for communication. So their actual vision is still very advanced, despite the fact they don't have colour vision. They have camera-style eyes that evolved convergently with vertebrates. So that means they evolved on separate lines, separate branches of the evolutionary tree.
Oh.
They didn't evolve so we evolved our eyes and then they kept evolving, then octopuses evolved from that. They're two very different lineages, and they both evolved the same thing, coincidentally, to cope with the same.
Wait. Oh, okay. I misunderstood that again. I thought you were saying that the octopus, each eye, evolved differently within the eye. No, but their eyes evolved differently to our eyes, but they accomplished the same things, but it was in a different tree.
Yeah.
So different journey, same result. Ish.
Yes.
Yeah.
That's convergent evolution. They can see polarized light, and coeloid cephalopods also have, that's the coeloid cephalopods are the octopuses, squids, and cuttlefish. They have microvilli in their eyes to detect polarized light. We talked about the microvilli when we talked about mantis shrimp as well, and you hated it because I described it as tiny little hair-like structures.
Oh yeah.
They're super close together, so it only lets one specific wavelength of light pass, and that's the polarized light. But polarized light allows even transparent things to stand out. So sometimes in the ocean, fish can appear transparent to blend in, but they'll stand out to an octopus. They can also estimate distance, because apparently polarization intensity changes with distance in water and also with depth. So it becomes less polarized with depth. So they're able to sense distance and depth in the water column.
That's quite interesting.
Yeah. The exception to this fancy eye stuff is the nautilus. They have very primitive eyes. They lack a lens.
What does the nautilus look like?
The nautilus is the one that's in the shell. It's the primitive one, so it's like the ancestor.
Oh yeah, the swervy guy that looks like a shrimp and an octopus mushed together.
He's stuffed into a shell.
Yeah.
That's him. They have pretty primitive eyes. They lack a lens, so they can't focus. So they can't do this fancy stuff.
They can't focus? Couldn't be me. I say as I take 10 different tangents and adjust my glasses. That joke hit in so many different levels.
Loved it. Yeah, they can only see light and dark, basically. That's all they can distinguish with. Their silly little eyes.
Silly little eyes.
But most cephalopods might not even need their eyes to camouflage, because their arms contain neurons, and they contain local sensory bundles and have a central nerve bundle, meaning they can detect light independently of the main brain.
Oh, I'm going to need to sit with that one for a second. So
We will speak more on like the specific arm intelligence in the next episode. But for this, they have sensory things on their arms that allow them to detect light separately from the eyes.
by touch or by like feel? What my brain is saying there is like, is it like, oh, they put their, I was about to say paw. They put their arm. So they put their arm on a rock and they're like, cool, this rock is brown. Or they're like swimming over the rock / they like, the rock is within the vicinity of their arm and they're not actually touching it. And they're like, cool, the rock over there is brown. Is it like
It's not
Daredevil kind of vibes?
It's not specifically touch.
Yeah.
So what a study did to kind of discover this was that they shone different types of light on different parts of the arm and then recorded what the response was. And there was neurons that were activated when light hit an arm, which hit a part of an arm, which triggered a colour response. And it's likely because of these things called opsins, which are typically found in eyes, and they absorb photons, so light pigments.
Oh.
They absorb it.
Like a plant.
Yeah, like chloroplasts.
Yeah.
Yeah. So they can sense they absorb the photons that are emitted from the specific light, and then that provokes the reaction for them to change colour. So light hits the skin, opsins absorb photons, an electrical signal is generated, local arm neurons activate, and then that changes the colour.
That's crazy.
Wild, right? They're not entirely sure. This is not confirmed. This is exactly what it is because they're still researching this stuff. But that's the going
Is there
theory.
anything that they have fully confirmed / I am confident, I'm staking my claim on this is it, about anything that is in the sea?
I mean, you can't. There's always someone who disputes something, and there's always like, well, technically, and then there's always the bloody
exception to the
outlier.
rule. Yeah.
You think you've got it, and then another fish swims along and goes, actually. There's an octopus.
Well, actually.
There's an octopus called a blanket octopus, and the sexual dimorphism between the men and women, so the difference between the sexes, is so big that they thought they were totally different species to begin with, and then found out that's just the female version of the male.
Weird.
Yeah.
What's the differences?
She's a lot bigger and longer arms.
Was he like, did he develop to be smaller so he could like, in and out real fast, detach the arm, drop the load, and then...
Let me tell you, cannibalism is rife in octopuses. They don't care.
They really don't. That was one of the main things that I knew about them is, actually, that was a squid.
This is probably why they don't hang out with each other, because they're like, it's too risky.
But I think it was like, they were like fishing and they were trying to get a live specimen. But every time they caught one on the reel, it would be killed and half eaten by other members of its species as it was coming up the pot. And they were like deep sea fishing. Like, and they had like so much technology, cameras, everything.
Yeah, I think it's the Humboldt squid that do that.
Yeah, that's crazy.
Humboldt squid are so aggressive. They have hooks. Their suckers have hooks in them.
Yeah, and that's like one of the issues they have with it as well, where they're like, by the time like the squid comes up, like it's just there's nothing to even look at anymore.
Yeah, they hunt in huge packs.
Yeah.
This study about the photons in the arm thing, they found that blue light produced the strongest response, and that's just because blue light penetrates deeper in the water. That's the last point I had on it. In addition to using camouflage to avoid predators, cephalopods also use their colour changing as a form of communication. The theory that they might use polarized light as a type of private, secret communication.
Like Morse code.
Yeah, the mantis shrimp, they think also might do this because nothing else can see the polarized light, or not a lot can see polarized light, so they might be flashing things on their skin that only the other octopuses can see. So they might be bitching about you right to your face.
I mean, I wouldn't be surprised, except for I'd be surprised at anyone to bitch too.
Because they have no friends.
Yeah.
Yeah, because iridophores that I talked about for reflecting light, they don't just reflect different colours, they also reflect polarised light as well. So that's how they think they can send signals. And depending on the angle and the spacing of the iridophores, they can reflect shimmering colours, metallic flashes, and polarised light. They think squid and cuttlefish use it in this way more than octopuses do, because squid and cuttlefish do have friends.
They're not miserable bastards.
They hunt in packs, they mate in packs. They do.
Yeah.
Not packs, shoals. They mate in shoals, they hunt in shoals. They do a lot together, so they have more reason to be communicating with each other during those activities.
Yeah.
But it's not proven, because it's pretty difficult to observe these species.
How cool would it be to? Like, how much would you pay
to watch them?
To be a fly on the wall that they wouldn't eat. Like, oh, you know the Magic Bus thing? You never remember that TV show? It's a really old TV show. I only saw it because Ireland's like 20 years behind everybody else. When it comes to everything. Yeah. But like, so it's the Magic School Bus and the teacher's like definitely giving the kids acid or something. But they all get on the school bus, they shrink down and they like disappear into something, and it could be like into a person. And like they go through like all the organs and like the digestive system or whatever, or they'll go like fly around like hippos, or it's like an educational show or whatever, and the kids all learn something. But like if you could do that for octopus, how cool
that would be so good. You know, Sam,
like squids.
You know, Sam, my husband works in Apple, and I did a demo of the new Vision Pro thing, and they show you a video and it's like you're underwater and there's lots of sharks around you. The first thing I said, and I had this thing on, was, can I put a camera underwater and then like put this on to live under the water and see it? Can I do that? That would be so cool. I would love it.
Oh, that would be cool. All right.
Some patterns that they produce have been linked to very specific behaviour, such as patterns that correlate with aggressive or dominating behaviour. So like zebra stripes, dark coloration, and lateral body displays are associated with aggression or a male trying to appear dominant during mating. Some display what is known as passing cloud displays, where dark bands travel along the skin. This is also either an aggressive message or a sign of arousal.
It's a fine line these days, huh?
It's a fine line.
It's a fine line.
Maybe they're still hate fucking.
I can't tell whether you're angry or aroused. Maybe it's both.
Let's find out. I'll detach my arm and see what happens.
So, could you imagine if you like misread like the literal smoke signals that they send? And like you're a male octopus, you detached your arm and you're like, yeah. Oh. Wrong one. Can I get it back? I can't do that again for months.
There's actually, I think it's either squid or it's cuttlefish, but there's something that the males will pretend to be females during mating so that the females feel less threatened and the dominant males leave them alone so they can sneak in. And they'll like change their coloration rapid as soon as they catch a female's eye.
The definition of a nice guy.
So flashes, silver coloration, shimmering mantle patterns are associated with courtship displays. The Caribbean reef squid displays bright color courting patterns on one side for females, and then on the other side it has an aggressive pattern to deter males. So one side is flashing stripes, come hither, and one is dark and aggressive. He's not the same when he's with me. One side's aggressive, saying fuck off.
Get the fuck. Another, like, oh god damn it went out of my head. I was gonna say another joke about like how they were like half and half. Like, me ma's a muggle. me dad's a muggle, me ma's a witch. A bit of a nasty surprise when he found out. I'm half and half.
That's funny. Well done.
Yeah, that definitely wasn't problematic with the only Irish person being there, the one who blows everything up. You didn't notice?
Man, J.K. Rowling.
J.K. Rowling, she's so fucking problematic, man.
She's so unhinged.
Like, genuinely, the only, like...
Like, you can tell this was written in, like, the 90s and the early 2000s.
Like... Yeah.
Damn. So today we've learned that cephalopods are much more than masters of disguise. Their skin is basically a living display screen that can change colour, texture, brightness, and even polarised light in milliseconds. What's your favourite fact?
I didn't know that they were like... I didn't know the bumpy bumps, that they're like separate to it. I thought they were just ugly motherfuckers, but we're bumpy. Like, I didn't know that they controlled that. I thought it was like, cool, that one mostly lives in rocks, so it has a weird texture and it camouflages into rocks, but it has that texture. Mm-hmm. I didn't know if you took it out of that thing, it would lose that texture. That's crazy.
Yeah. I like that the chromatophores are neurally controlled, not like hormonally.
Yeah.
That was pretty cool. Anyway, let us know what your favourite fact was about octopus camouflage or octopuses in general. Let us know in the comments. Like, subscribe, share, tell your friends and family.
Yeah, force them to watch it. Listen, not watch. Force them to listen to it.
Anyway, take care and stay curious.
Bye.